Hello, how's it going?
How are you doing, Joe? Where are you calling in from?
Where I'm in Canada.
Canada, a lot of Canadians tonight.
Yeah, nice.
Yes,
What's
sir.
your question?
Tim Hortons.
Yeah, I just wanted to ask you about evolutionary theory because uh, I'm in university right now, and when I go through my classes, I look at uh, endosybiotic theory, identical patterns of viral insertions in bacteria and archaea, um, just all this stuff. How every single, or not every single, but unbelievable numbers of proteins and enzymes share homologs across organisms completely, yeah, things like that. And when I see that for every single system, and then I am asked to accept something like creationism, I mean, what would you say about that? What am I supposed to do with the fact that there are litters of endogenous retroviral insertions in our DNA that are almost identical with chimpanzees? This is not something that's created. These are accidental viral insertions.
Right. Okay. Before we get into it, have you seen any of my content on this?
Yeah, I've seen a couple of Muhammad Tijani's videos. I've seen some of your videos. I've seen your debates with Aaron Ra.
Okay. So, firstly, do you have, and let's start off with the easiest things. Do you have a problem with the way that I define evolution and the way I define Darwinian evolution?
I can't recall your exact definition off the top of my head, but can't we proceed without um, a specific definition, because that seems about impossible to agree with when you're debating stuff in a religious format. Can't we just ask whether or not we have a common ancestor with chimpanzees? Can't we
Um,
just proceed on that framework?
yeah, you see, this is what I disagree with. I disagree to start off the conversation without us actually agreeing on what definitions we're going to use. Now, what I don't mean to say is that we need to go over, for example, 27 plus definitions of speciation, right? I'm not saying we have a debate about which one of those 27 plus definitions is correct, but we can say, well, let's stick to this definition for the purpose of this debate. So, firstly, do you have a problem with the idea that natural selection and the tree of life coupled together, this idea that natural selection working on random mutations is the mechanism of Darwinism, and the history is universal common ancestry and the tree of life? These are the twin propositions of Darwinism. Do you have a problem with that, or are you okay with that definition?
I would say natural selection is the primary mechanism of evolution. I would not say it's the only one, and no modern evolutionary biologist would say it's the only one. But
Right.
yeah, I would say it is a
Yeah, and
yeah.
yeah, you're absolutely spot on, because even Darwin didn't say it's the only one,
Yeah.
right? So that's fine. So when it comes to this idea, do you first off agree that the history and the mechanism are linked to each other?
The history of evolution.
The history of evolution, as in the tree of life, is linked to the mechanism which is being proposed.
Yeah, sure. The way evolution proceeds is linked to how it happens over time, of course.
Of course, good. I'm really happy you did that. The reason why I'm happy you did that is because some Darwinists, and I'm not saying you're a Darwinist, I'm saying some of my opponents, they refuse to accept that. But I'm glad you did, right? Because it's like a bridge. You got one section here, you got the road there, and the mechanism and the history are intrinsically linked. Now, the first thing to note is that on a popular level, we have been hoodwinked, we have been lied to. There's been mass propaganda in terms of the way that natural selection is supposed to be this blind watchmaker that can explain our biochemistry, our genetics, our anatomy, our psychology, our linguistics, the understandings that we have from anthropology and so on and so forth. All of these things. Yet what we find when we go into the academic literature is actually there's a lot of disputes, discussions, and disagreements when it comes to natural selection working on random mutations being enough to explain biodiversity. Do you agree that this is a hugely controversial area?
That natural selection is the sole mechanism. Is that what you're saying?
not the soul. You can call it the soul, or you can call it the primary mechanism. Basically, Darwin's main idea. Do you agree that the way this has been publicly churned out does not reflect the understandings in academia?
To be honest, I don't follow that much the popular discussions on this. I try to read the literature. I take my courses. So if we could just discuss, the actual fact of the matter, I don't care about how people discuss it. I think it's
important. Well, I think it's important because if the public has been lied to, then that's important, isn't it?
Yeah, but I'm not 100% familiar with how random people talk about this. I'm more familiar with the academic side.
Okay, if you're familiar with the academic side, then is this the idea that natural selection working on random mutations, this is the primary, in your words, the primary mechanism to explain biodiversity, to explain evolution? Is this the view that is held by academics?
I would think that natural selection is usually seen as the most important method, yes.
Okay, so the answer to that is yes. You believe that academically this is the primary mechanism. And are you aware of any disputes in this regard?
I've heard of some people say maybe they've made their own mechanisms. Yeah, I've seen a few people who have selected other mechanisms as maybe more important, but dominantly, I don't think natural selection is dominantly seen as the most important one.
Let's forget some people, because you said you just want to talk academically, right? So yeah. Academically, you've made a claim, right? You've made a claim, which is that this is seen as the primary mechanism, right? And I'm challenging that and saying, actually, academically, this is a controversial area. I can provide evidence for what I'm saying, but before that, I just want to know, do you understand that we're on opposite ends here?
Sure, you're saying that there are other people who say there are other mechanisms that are more important, but regardless of how you weigh the differing components, you don't get a different outcome in that there is a common ancestry or something like that. That remains relatively the same.
Well, there's two problems. There's two problems with this. The first problem is I feel you're evading the point I'm trying to raise here, which is that the idea that you previously said, which is that natural selection working on random mutations is the primary mechanism, and this is generally agreed upon in academia. I'm saying that's false. And you just want to move to common ancestry, which is fine. We're going to go to that next. We're going to go to ERVs. We're going to go to homology. We're going to go to all of that good, great stuff. I love discussing this stuff till the cows come home, right? That's not an issue. But let's first, step by step, we spoke about definitions. Now let's go to the mechanism, and then we'll go to universal common ancestry. But each one of these things has to be gradually followed. I feel you're jumping a bit. So let's just finish off this point. You're saying it is the primary mechanism and that is accepted within academia. I'm saying no. In academia, what we find is that there is dispute. There is major disputes. And previously what I said to you, you said was irrelevant. I don't think it's irrelevant. I think it's very relevant. It's very relevant that the public has been lied to. It's very relevant for the last 150 years that natural selection working on random mutations, the so-called blind watchmaker, was used to explain the intricacies of biochemistry, the things we find in paleontology, all this stuff. And what we find is that in the public domain, things like the Big Bang Theory, these popular TV programs or documentaries, you get this continuous idea that natural selection is this powerful creative force. Yet when you go to academia, you find that they're actually challenging this. They have alternatives, as you alluded to, like natural genetic engineering, like neo-Lamarckism. In 2016, and the Royal Society in London, remember, the Royal Society is the oldest scientific society in the world. In 1858, Darwin actually published with them. So he presented his idea, and the year later he published his book, The Origin of Species. In 2016, you had scientists, secular scientists, who came from different parts of the world, and they came to discuss the very proposition of Darwin, which is natural selection being the main mechanism of evolution. And you have scientists on one end who were supporting neo-Darwinism, and you have scientists on the other end completely disagreeing with neo-Darwinism. So what we basically find is that the public perception is not true. The academic ideas that we have is that of disputes, disagreements, and alternatives. So what you were saying before, before we get into ERVs and common ancestry and all of this stuff, is false. That's just something I want to clarify.
Okay, even if it was false, because I do not necessarily concede that, but let's say that it is false. Let's say that you're completely right, that there's a complete open-ended discussion about the relative importance of different mechanisms. If I were to concede all of that, what is the next step of the discussion? Because what I do want to discuss, rather than the theoretical side of what we generally say of our framework, I want to discuss the specifics. I will accept everything you say if we can move on to that part.
Yep, that's absolutely fine. We can move on. So the next part, which you said, which we were speaking about universal common ancestry. Well, the first thing to know is if the mechanism breaks down, if we don't have a mechanism anymore, then all we simply have is what we had before Darwin, which is the idea of homology. Now, if the mechanism breaks down, then the history also breaks down. Then the history is also up for grabs. The mechanism informs how you can actually make the history as well. So as to what you said right in the beginning and you agreed to, which I told you my opponents disagreed to, the reason why they disagreed to this idea, which I said right in the beginning, which you agreed to, is because later on in the conversation, which is the point we are speaking at right now, you are in a bit of a pickle, which is if the history is which is if the mechanism is being challenged, then the history is also being challenged. So that's the first point that I want you to understand. Based on what you said earlier, the mechanism being challenged would also challenge the history. Why? Because the idea that there is a tree of life, the idea that homology is due to common ancestry, these ideas were known before Darwin. They were known at the time of the Lamarck, and going all the way back, it was known at the time of the ancient Greeks, the ancient people of the Indus Valley civilization, and others. So Darwin came and put his 2 cents, which is the mechanism, which is why the idea of the tree of life took off. But as you should know, if you're studying evolutionary biology, tree of life is way older, way older. So now let's move on to why it's not enough. It's actually not enough to simply use homology as a way to prove universal common ancestry.
Homology is not the only way to suggest all the things we have.
Homology is the primary way that phylogenetic relationships are inferred.
There are many ways. Let me comment on one way to talk about a complete common ancestor.
Okay, before we get there, do you disagree with my description of evolutionary history in terms of phylogenetics, that the primary method that they use to infer genealogical relationships is via homology? Do you disagree or agree with that?
Homology by itself, without interpretation, just saying two things are similar without interpretation, does not get you a relationship.
I never said that.
Yeah, of course, and evolutionary biologists do not say, well, these are similar, therefore they are related.
I don't think you're understanding my point. So let me just repeat it. And I'm not actually making a controversial point. I'm just describing that phylogenetic history is inferred using homology. Yes. That's the primary way. Do you agree with that?
Yes.
So why were you trying to show I'm wrong then? Because I've said something non-controversial. I've said something benign. No, I don't understand what you're trying to achieve there.
No, listen. It just sounds like you're saying it's the only way.
It's the primary way.
In some contexts it is. In some contexts it's not.
Okay, I'm going to repeat it again. It is the primary way, because whatever you're going to do now, in fact, in the beginning you just mentioned ERVs, which are essentially an argument for homology.
No, it's more specific than that.
What? Wait, 1 second. In the beginning, you used an argument from homology. Are you denying that now?
I'm saying it's more specific than just homology. I did make that argument, but I wouldn't.
Okay, firstly, let's do something here. Can you define for me what you mean by homology?
Homology, it is, as opposed to analogy, it is similarity is due to common ancestry.
Okay, That's a very interesting way of putting it. So you're saying homology is similarities due to common ancestry. Now,
Yes.
the problem with this definition, it's fine, you can define it in that way, but there is a problem with this definition, is that prior to Darwin, homology was primarily defined as similarity in structure and function, and that was it. It wasn't due to common ancestry. Now, if we have the definition, similarity is homology is similarity due to common ancestry, then of course any two things that look similar from a biochemical perspective, ERV perspective, genetic perspective, anatomical perspective, from bioinformatics or linguistics or whatever, we can simply say similarities are due to common descent, similarities exist, therefore similarities are due to common descent. But that's actually circular reasoning.
That would be circular reasoning, but I'm not saying that.
Yeah, but the definition you used is self-serving, though. The definition you used, and anybody can go back and timestamp this. The definition you used is similarities due to common descent.
Yes, it is, and I'm not making a circular argument. But can we discuss the specific example I brought up that you brought up again?
So okay, let's just look into this first, right? If we define homology as similarities due to common descent, okay?
Sure.
And in the beginning, you used ERVs. You said these are accidental insertions, and these insertions for you were evidence of human chimpanzee, correct?
Sure, and yes.
Okay, good. Now, what you've done there is you've basically said this. Remember, this is from you. I'm not misrepresenting you. I'm just using whatever.
I'm not saying you are.
No, I'm just saying it. Your definition of homology is similarities due to common descent. Then ERV you're using in humans and say chimps, and you are basically looking at them and you're saying, look, these are similar, and your conclusion is therefore they have a common ancestor. That's the classic circular reasoning argument you just used.
I did not say therefore from that one point. If you could let me explain the point at more length, I could.
Oh, sure, go ahead. But I hope you don't make that mistake, because I've found that when people say you've misrepresented, like I had this, I've had a few debates like this.
Okay.
When I tell people they're using a circular argument, they usually go and explain the same point in a different way, and then have to point out again it's actually still a circular argument. You're just trying to get around it. But you go ahead.
Sure. So viral insertions are by definition accidental, because when the virus enters the cell and it integrates into DNA, there is no specific spot it will necessarily integrate its DNA, especially depending on the virus. There are all sorts of places it can insert, and our genome is completely littered with potentially hundreds of places where endogenous retroviruses have inserted their DNA. And if you take a look at a chimpanzee's genome, or not just a chimpanzee, but also other apes as well, you can see that the ERVs are also inserted at virtually the exact same spot within the boundaries of other genes that we can identify.
Yep.
And so, from an evolutionary perspective, it's so obvious how this could resolve that it's not even worth describing. But from a creationary standpoint.
Wait. One second here.
Yes, sir. Go on.
Okay. You just said you weren't concluding. You weren't concluding just using that they have a common ancestor. And then you're saying, well, you have these accidental insertions here and here, and it's so obvious. You just did exactly what I said.
Here's the distinction. If you give me a second, the distinction is you could say they are similar, therefore it's similar. It's similar, therefore it's a common ancestry. But I'm saying what tells us that it's a common ancestry is that these are supposed to be accidental insertions happening in hundreds of places at the exact same places. This is not just similar. This is a case of probability.
Okay, so what you're doing is you're using an additional label of accidental insertions.
Yes.
When you strip that away, you're still using at rock bottom. Your skeletal structure is still an argument for homology.
You can label that if you want, but
no. Wait.
Okay, yes, it's a similarity, but it's a similarity.
Thank you.
The mechanism.
Wait. One second. Please look. Yeah. There's no point doing this. I've done this a million times, right? I mean, it is an argument for homology. So let's stop faffing around there. The other second point to keep in mind is you use the word accidental insertion.
Yes.
Now, what's important to know, and since you study evolutionary biology, you would know we need to be careful when we use the term accidental, when we use the term vestigial, when we use the term pseudogenes, or when we use the term junk DNA. And the reason why, and I hope you can, I hope you're not going to challenge this, because then I'll have to fact check you again, is that those labels have in the past been shown to be problematic, because things that we believe to be pseudogenes were actually functional. We had the whole entire study from ENCODE, the Encyclopedia of DNA Elements, in 2012. And actually, this is part of my my master's dissertation. I actually wrote about this. That Darwinists were basically saying junk DNA, God needs to go back to school and all this type of stuff. And for many, many years, this wasn't even investigated. And later on, we found out actually 80% of what we call junk, according to a study, is not actually junk, but it's actually functional. So again, with these accidental insertions, and you use the word insertions here, this from a creationist perspective, a common design perspective, is the same as, for example, the idea that we have a lot of bacteria. So this could be part of the creation narrative. There's no inherent problem with that. The problem that does actually exist is when the ERV argument is used as an argument as if it's not based upon homology, because the whole problem with homology, and I really want to destroy it from its very root. The main problem with the argument from homology is that if you use it in a circular way, then obviously it's not valid. However, if you use it in a non-circular way, and there are non-circular ways that the homology argument can be used, something like the maximum likelihood method, and they would use all these probabilities to do that, they are still assumptions that you need to make. So for example, can
I comment on a few things, because you were saying a lot here?
Okay, let me just complete this point about origination probabilities. Yeah. So, and I had Dr. Paul Nelson on this channel, about 5 times, and we discussed this in some detail. So the thing is, we have transition probabilities and origination probabilities. Are you aware of this distinction?
Can you repeat that?
Transition probabilities and origination probabilities.
Could you define those?
Are you not aware of this?
Not specific terms.
Okay, then I would simply put it this way, right? I will explain it to you, but if you do not know this distinction, then don't bother trying to use the argument for homology, because this is the very foundation of homology. It's basically like someone saying, I'm going to try and solve this algorithm, but I'm not going to bother with BODMAS. I'm not going to bother with addition and subtraction. The very basis of homology is origination probabilities and transition probabilities. And if someone doesn't know those, then don't bother using the argument for homology. It's actually ridiculous.
Okay, so what's the huge distinction with ERVs here? What is your explanation for the origins of ERVs? Because listen, because you cut me off and I was trying to explain something. You're responding to a circular argument of similarity, therefore ancestry. I'm speaking to the mechanism by which the similarity arose. I'm not saying like post facto we have a similarity. I was referring to the mechanism by which the similarity started, and that mechanism was a viral insertion at a specific point in many places, and you have those across the genome. It's an argument from the mechanism by which the similarity arose, and you don't get those hundreds of insertions at the same points by random chance unless you want to give an argument as to another plausible way by which we get this. You could say, for example, that God inserted the same viral sequence, non-functional viral sequence, at the exact same point in hundreds of places, and made it appear as if there is a common ancestry. But that seems a bit all, starting with the beginning here.
Okay, so firstly, let's just clarify something, right? I don't want to misrepresent you. You do admit this is an argument from homology, but the type of argument it is including the mechanism of accidental insertions.
Yes, the mechanism by which the similarity arose.
Sure. In that case, it's still something which we can challenge using the basics of homology.
Right.
If it's an argument from homology, which you previously said it's not an argument from homology, essentially it comes under the same origination probabilities and transition probabilities and homoplazy and all the previous stuff that I've actually covered. However, I just want to ask you a simple question just to make sure I'm not misrepresenting you. You're saying accidental insertion, correct?
Yes, the viral DNA does not insert at a specific point ahead of time.
Sure. Now, that being accidental, and I assume you also are going to say it's non-functional.
Yeah, viral DNA typically, as far as I'm concerned, I think I've seen maybe one example of a different virus in a different species.
No, that's fine. That's fine.
Sure, yeah.
Okay. So, two things: accidental and non-functional, right? Are you saying that you can you can actually say with certainty that this is accidental and is also non-functional?
Yes, we can observe ERVs inserting all the time. They don't fit into a preordained spot.
No, what I mean is, are you saying this is certain? It's certain that it's accidental and it's certain that it's non-functional?
Certain in terms of all the events we have ever discovered, yeah, sure. But what is your alternative?
No. I mean, I just previously mentioned junk DNA, which was supposed to be, non-functional. It turned out to be functional.
Well, not all of it. The ENCODE did find that.
Wait. Hang on a second, yeah. First, let's agree, rather than saying not all of it, 20%'s left. Let's first agree that the Darwinists were dead wrong here. They were dead wrong when they claimed it was all junk.
Yes, anyone who said it was all junk was dead wrong.
Wait. What did you say? Did you say they didn't say this was all junk?
No, I said yes. Anyone who said that it was all junk was dead wrong. But also,
and by the way, just so I enjoy this point a bit, that does include people like Richard Dawkins who are very vocal that it was. Yeah. So he's dead wrong. Okay. Yeah. It does actually include people like Philip Kitcher, who was, is a militant atheist. It does include people like P.Z. Myers, who is a new atheist. I just want to embarrass these guys because I like how candid you are, that these guys were dead wrong. Okay. Now, the idea that these things are these are non-functional. Okay. Could it not be the case that we discover there's a function to these ERVs as opposed to them being non-functional, just like we did with junk DNA?
Can I wait before I answer that? I want to make a point about something you brought up while you were explaining that. Sure. You said you gave the number of 80% is functional. Now there's a criticism of this figure because it's not that 80% is functional. It's that 80% of our genome is transcribed, which is not the same as functional. You could have stochastic processes randomly transcribing certain parts of the DNA, but by ENCODE's definition, they predefined any transcribed regions as functional. That's not necessarily the case. That was one criticism that scientists made of the way that ENCODE defined things.
Okay, let me just highlight something. Yeah, scientists that were criticizing ENCODE, scientists like P.Z. Myers, who was the most vocal critic of ENCODE.
No, not him.
Okay, who then? Who?
I don't have the name off the top of my head, but the point I made is pretty valid.
Okay, let me just be frank.
But it was not P.Z. Myers. It was not some atheist activist.
P.Z. Myers led the charge against ENCODE, and he's an embryologist.
He was not the only one, but sure.
No. Okay, but let's be frank here, yeah. ENCODE study was something that the Darwinists for many years discouraged. Do you agree with that?
Yes, and I'm not disputing that. I'm referring to the specific.
No. I think it's important. I think it's very important to show what the Darwinists were up to for decades. Yeah, because as we know, we discovered that the information once ENCODE published his studies about switches, right, which has actually allowed us to fight things like diabetes. This information, which is an epistemic good, I hope you agree with me, it's an epistemic good. For decades, there was discouragement from the Darwinists not to basically study junk. It was seen as a waste of time. So when you say to me, the scientists which are attacking ENCODE I mean, I would love for you to, mention who they are, but whoever they are, right? Who cares what they think when the first point to know is the Darwinists were dead wrong. And the reason why they were dead wrong is because they had ideological reasons to believe that junk DNA was there. However, the thing which I push for, and I hope you push for, and we all should be pushing for, is ideology has no place in biology. Biology should be free of ideology. And the same thing is happening here with the ERVs. You're saying they are non-functional. I'm saying, what makes you think that that is the case? We have the problem of induction. We have the problem of underdetermination, the problem of unconceived alternatives. It's shown us in the past that junk DNA, which, as Philip Kitcher said, God should go back to school. He should go back to school because we actually discovered it actually has good epistemic. It has epistemic goods. It helps us, solve diseases and stuff. So what we need to recognize is that there has to be this epistemic humility from the Darwinists. You can't just say it is categorically non-functional, and you know better than that.
Okay, Subboor, I was only referring to the figure of 80%. I know that they got it wrong. Listen, are you saying? So wait, can I just ask you? Do you disagree that these are, first of all, viral DNA? That this is viral DNA?
Our current understanding is that's what it is.
Okay, if I asked you personally, are you convinced of that?
I am convinced that according to the best understanding that we have amongst the scientific community, that's what they have labeled it as. But I do not believe categorically that we can say it's accidental. I do not believe categorically we can say it is non-functional, because we have been proven wrong in the past when it came to junk DNA, and it can happen again here. Plus, it's not enough. Even if I was to hypothetically accept that we can never find out if we will never find out if these things are functional. I still believe there is no way possible that this can be used as a decisive argument from homology for common ancestry, because of the distinction between origination probabilities and transition probabilities.
Okay.
Which, if you let me explain, then you will understand why it is such a huge problem for the Darwinists. And I'm surprised that you don't know this, because and you just check out the stuff on my channel. You'll get more in depth about this, but I'll explain it now as well. Once you understand origination probabilities and transition probabilities, you wouldn't bother using the argument from homology, even if it's infused with ideas from ERVs like you have, because essentially what it will show is it's all fundamentally based upon an assumption when it's not based on circular reasoning.
Okay, you would have to convince me that, but if you let me make some points here.
Well, firstly,
wait,
I don't.
Come on, man. You've been talking for 5 minutes.
Sorry, one second. I just want to clarify something. I don't need to convince you of anything.
Okay, let me just make a few points.
Sorry, John, 1 second. If you don't know the basics of homology, then it's not a case of where you're sitting there on a pedestal and I need to convince you of something. It's more like I'm looking down on you as an evolutionary student and thinking, how could you not know about origination probabilities and transition probabilities? So let's get the stakes in the right order here. Yeah? I don't need to convince you of anything. You just need to learn a bit more about evolutionary biology.
Look, I'm sure I know the thing you're talking about without the specific terminology, but look, if I can just make some points. So it seems that when I asked you my question earlier, you seem to say that per all our scientific understanding, these are actually ERV sequences because they are literally ERV sequences. We can observe how ERVs insert themselves into DNA. There is no preordained spot in which they will insert. So it's simply a viral sequence will not be transcribed by a RNA polymerase or DNA polymerase in such a way that it creates what happens to be a functional human protein, because we know what the proteome of the human genome is. We've studied it. We've cataloged it. A viral sequence does not automatically, in fact, it rarely produces a function, a literal sequence
Rarely,
of virus.
Rarely. Can you explain that a little bit more, please?
The word rarely, because I think I've seen one study in which there was some virus and some worm or something. I don't remember what it
Yeah,
was.
there isn't
In,
one
in
study.
which sorry,
There's actually plenty of studies. Yeah.
of ERVs.
Yeah. So what it basically is it's the problem of induction again, which I was referring to earlier. You cannot make a categorical label for these things like you're trying to do. The other thing to keep in mind
I said
is that
primarily.
from a common design perspective or creation perspective, we need to define a few things. So you said viral, and let's look into this area because it's a little bit hazy. It looks very clear, but it's not.
Okay.
What would you consider foreign and what would you consider natural to the human being? So obviously we have trillions of bacteria, we have these types of things. What is foreign and what is viral, or sorry, what is natural and what is viral or foreign? How do you define that?
Oh yeah, because of the nature of how long you could have had a certain sequence over evolutionary time within DNA. You could consider that. Wait, listen, I'm asking you a question. Just let me it'll be very obvious once I finish. You could have had an insertion a billion years ago that's still in us now, and you could say, given how long it's been there, it's native. So one way you could go about this is you could simply say something is foreign if it has maybe more recently been inserted into our DNA and has not been integrated as a functional component.
Right. You do realize that that's purely arbitrary, what you just said.
Sure. You asked me for a way, and I said I gave you a way of defining it. That works. Is there any problem you have with it?
No, the problem I have is that you don't have a categorical answer. You have a subjective value judgment.
That just sounds like you're demanding semantics. These are viral DNA sequences, are they not?
I think we're going around in circles here. Firstly, let's just stick to something. Do you agree that what you just said right now, that what you consider foreign or viral is based upon what's been recently, how long we've actually had it within our system? So you'd look at it from a chronological perspective, right?
Sure, that's one way of looking at it. That's not
right. And all I said here, and I think we should agree on this point at least, is that's a subjective value judgment, and I can come up with something else.
Sure, whatever you want.
Yeah. So if I was to use from a creationist perspective, the idea that God created, all of life, and if there were any insertions, all of this was divinely decreed, and these things were done independently. It's not based on homology. I can make that claim just in the same way you've made this claim.
So you make the claim. So you say it's the way I'm defining such a term is equivalent to saying that God divinely ordained viruses to insert hundreds of different places in the exact same place. Are you saying those are equivalent?
Yeah, I'm saying there's no way you can adjudicate between these two subjective value judgments.
All I gave was a definition. I didn't make a statement of what did or did not happen.
You gave a definition which is not categorical, which is essentially a subjective value judgment.
Okay, so are you going to say because there are more than one way to define the word foreign, therefore that's the equivalent of saying that God inserted DNA sequences of viruses in pattern sequences across different organisms?
Yeah, that would be a really poor argument. I think I want you to steelman me here. What am I saying? What do you think I'm saying?
What I think you're saying is I just gave you one way of defining foreign because that's what you asked for. And then you said that what I heard you say, maybe you want to clarify, is that you could, with equal validity, claim that God divinely preordained the insertion of all these virus sequences in the same place.
You missed something that I said in between.
Go ahead and clarify.
What I first said is that your definition is not categorical.
Yes, there is more than one definition. Is that what you mean?
What I mean is that it not only that there's more than one definition, but it is a subjective value judgment that you just gave.
What value judgments did I give?
That you defined foreign in the particular way that you did.
Sure, it's one possible way. Is there a problem with my one possible definition?
No, I'm just simply saying it is not categorical. So for you to then base an argument on a definition that's not categorical, because essentially what your argument is, and this is where I think, John, you are blurring the lines between theology and biology. Okay. Now, for you to then start saying, why would God do this? right? As opposed to this is, it can't be creationism because of this. The problem here is that you are blurring the lines. Now, there's no point for us, if I go into my conception of God is this, your conception of God is this, therefore you think this is not possible for God to do, I think it is possible for God to do that. What I do want us to agree upon is that the argument that you're using from ERV is essentially a homologous argument, and a homologous argument will not make sense unless we look into the foundations of homology, which is origination probabilities and transition probabilities.
Sure, and if you think there's another way you can explain it, you are welcome to give explanation. But I think the argument is very strong.
I don't think you understood what I was saying.
Okay, but I'm trying to understand you, but I think you're just delving into semantics. You're asking me to define things, and then I define a word a certain way.
I am delving into, okay, sorry, 1 second. I'm delving into semantics because your semantical definitions are essentially like a hazy box full of wires crossing each other.
But
so
I did not use the word foreign. You asked me to define foreign. I didn't even use that word. I wasn't providing any hazy definitions. You asked me to define a term I did not even use.
Did you use the word viral?
Yes.
Okay, and it was inserted.
Sure, and different people could say, based on their own personal value judgments,
I call that foreign.
Okay, so regardless of what you call it, what does it matter?
What's wrong with me calling that thing foreign? Do you not believe it's foreign? Sure, viruses are foreign.
Yeah, they are foreign. Or
so you use the concept. Maybe you didn't use the word.
Yeah, but
who's doing
what you call it? Look, no, listen.
Yeah.
You can actually define viral insertions if they're old enough and if they've been reutilized. You can actually define them as native in that case. But the thing is, it doesn't matter the specific term you use. The point is that they exist, and I'm trying to ask you about where we should see for their origins.
Okay, so let me make a claim, and let's see if you can challenge this claim.
Go ahead.
I think theologically, there is nothing wrong with me accepting ERVs, and that within my theology, I could explain it as God inserting those things. Everything is predestined. Like, it doesn't challenge creationism. Tell me why it's contradictory to creationism.
Yes, because we are making predictions here. Let's say we wanted to make a prediction here, and you could predict with evolution that the sequences of an ancestor will be transmitted to, the sequences of an ancestor will be transmitted to its descendants. And that's a prediction you could make. But then what you're taking on that creationism standpoint is you are basically saying that God is inserting these viral sequences hundreds of times in the exact same places between humans and chimps, and you're doing that for the sole purpose of back interpreting what is otherwise a pure evolutionary prediction in advance, and you are simply reinterpreting that into creationism. You're creating this very unclarified scenario only in order to preserve the presupposition. There's absolutely no reason to think that God would insert virus sequences in the exact same places hundreds of times between chimps and humans, but there's every reason to think that the common ancestor of humans and chimps had many viral insertions, because literally all organisms do, and therefore we simply see it in its descendants.
Okay, so again, you've blurred some things between theology and biology here. So, firstly, God creating within us, for example, bacteria. We have certain types of bacteria. For example, one particular type of bacteria helps us when it comes to digesting breast milk when we're children. So you are in no position to say what God can or cannot do. Secondly, when it comes to evolutionary predictions, so let's just get something right here. The Darwinists have been dead wrong. They've been dead wrong when it comes to gradualism. They've been dead wrong in their predictions when it comes to punctuated equilibrium. They've been dead wrong when it comes to their predictions about junk DNA. They've been dead wrong when it comes to their entire understanding of natural selection and what it can actually do. So there've been many predictions when it comes to Darwinism, which have been falsified. And in fact, when we have had a situation where anomalies pop up, like orphan genes, Darwinists have made counter predictions again, and they've been proven wrong again. So for you to say creationism predicts this and Darwinism predicted this, firstly, when you try to make predictions from a creationist perspective, you have to put on the lens of that creationist. Now, from my perspective, and I'm a creationist, from my perspective, God can do what he wants. From your perspective, you're trying to put God into a box and saying God can do this and God can't do that, and I don't accept why God can insert these things. And I would say, no, God can actually insert what he wants, and those things could actually be functional. You're saying they're not functional. And likewise, there are many, and this virus thing that you ERVs that you just highlighted now, this is one of the many foreign elements within the human being. There's actually, as you know, multiple foreign elements within the human being. In fact, there's a whole discussion about even what makes us human, because we have more non-human, supposedly non-human cells than we have things like bacteria and stuff. And of course, I wouldn't agree with that, because I would define foreign as something different. The problem here is you're trying to use something in biology to challenge theology, but in order for you to actually do that, you are jumping across two different fields, and that's where the problems are coming. So what I'd like to do now is explain to you the difference between origination probabilities and transition probabilities, because essentially your argument is an argument from homology. And if it's an argument from homology, then regardless of what you use, whether you use ERVs or you use something in biochemistry or whatever, it still has the same issues.
Can I make a few comments before you go on to that?
Yeah, sure.
Yeah, I've never said anything about what God could or could not do.
You did.
No, I make no claim about possibilities, because an omnipotent being can do anything.
You said, why would God do this? Or
what I said, let me clarify. Maybe I even misworded it. I don't think I did, but if I did misword it, what I'm saying is that you have. And by the way, I'm going to bring up predictions again. So because you commented on that, it's worth also making a comment on that.
When you do bring up predictions, do you realize that?
Yes, I want to comment on that because you said something about it. So let me comment on that.
I showed a whole bunch of predictions which Darwinism got wrong.
Yes, and I want to comment on that. Evolutionary biologists have made right predictions, and they've made thousands of correct predictions, just like in every other field of science.
Wait. 1 second. Sorry. I'm going to have to stop you there.
Yes.
Thousands of correct predictions?
Yeah.
Just give me 5.
Give you 5. One of them would be the ERV sequences. Another would be the discovery of many.
No, that's the argument. That's not a prediction. That's simply a reconfirmation of homology. Try another.
That is not a reconfirmation of homology. Evolution says, listen.
Essentially, what is it? It's an argument that you have this particular insertion, you have this particular insertion, this is due to common ancestry. That's it. And this was known at the time of Darwin. So you can't say something in homology is a prediction, when actually homology from their perspective, they make, and look, I'm just going to explain it because you didn't give me the chance to. They make the origination probability 0 or close to 0, and they make the transition probability close to 1. Those two things they use coupled with homology, and then they say universal common ancestry is true. But these two things are assumptions. It is an assumption that the origin of life is close to 0, that abiogenesis is rare. That's an assumption. It's an assumption that transition probabilities, that you can have these major macro evolutionary changes, is close to 1. This is again a total assumption. You cannot say these are facts. So when you say thousands of predictions, don't use something which Darwin used, right? That there's nothing new about that. This was known before Darwin.
No, it was not known. Genome sequences. Listen,
listen. I think you're completely misunderstanding me here. Look, when it comes to biochemistry, anatomy, ERVs, linguistics, anthropology, if someone's going to use an argument from similarities, it doesn't matter how deep you go, whether you go as deep as biochemistry or zoom out further into anthropology or into anatomy, you essentially are still using the same argument from homology. You can't keep saying, Look at these two things. They're similar, therefore homology. And as if you've said something new. Like, okay, give me some predictions.
Okay, look, so homology doesn't count for any prediction. Okay, how about transitional fossils? Do those count as predictions?
Transition fossils would do, yes.
Yes, there have been many dozens of hominid species discovered. Would you like to dispute that before I move on?
No, I would not dispute that, but remember.
Okay, so let me keep going. So
okay, wait, one second. You can't throw out something half.
Okay, go ahead.
Yeah. So firstly, Darwin spoke about the Cambrian explosion. He spoke about this being an issue. And the problem with the Cambrian explosion is he thought it was going to get resolved. However, it got worse over time. The second thing is that
no, it did not.
The second, yes, it did. I mean, just look into what a disaster it was to try and explain, this explosion of life. The Cambrian explosion is a serious problem in anthropology. We have people like what's his name, Stephen Jay Gould. We have Richard Lewontin. We have these people in paleontology who speak about punctuated equilibrium, how gradualism is dead, how the lack of gradualism is a trade secret in paleontology. We have these absolute failures of gradualism, which is why punctuated equilibrium had to be reintegrated into neo-Darwinism. So for you to say we found hominid fossils, finding hominid fossils is not enough to solve the problem in paleontology that actually exists for Darwinism. So this is not some amazing prediction or some amazing confirmation. And I'm surprised you're actually going down the paleontology route. If you are aware of the problems with the Cambrian explosion, you wouldn't be using this.
We could talk about the Cambrian explosion. We could talk about the Ediacaran fossils, but let's specifically talk about, because the Ediacaran fossils are an earlier phase of the Cambrian fossils. But
right.
Let's talk about what I brought up, the hominid fossils, because we start with, and these are sequential. We start with these apes, which are living in trees, or they're adapted to live in trees, and then we have fossils of apes that have mixed, let's say, lifespans. They can both go around on the ground and they can live in trees.
Yeah.
And we have, and this comes after. That's not before. That's not contemporary. That's after. And then later on, we find fossils of apes that specifically live across the ground. We have gradually evolving skulls of fossils in a perfect, not minus the, okay, let me not use that word because I know you want to jump on it, but we have a linear development of skull size, all sorts of traits towards the fossils of Homo sapiens. We have changes in even cranial developments that register the development of different brain regions over time towards modern humans. We have genome sequences of even Neanderthals, which show that perhaps there were some genes like the specific variant of the FOXP2 genes, which even if they don't give the Neanderthal full ability of language, Neanderthals very well may have had the ability to speak. And we have earlier fossils, I don't know if it was Homo erectus or a different one, which had another prior development to that, somewhere maybe in the neck or the throat, which gave it an enhanced ability to speak like we do. So there is all sorts of linear developments over time that continue appearing towards the current trajectory of Homo sapiens. And that is a transition in every possible sense.
Okay, so let's clarify this. When you say transition, do you mean that you can put these fossils in an order and say that these are the ancestors of humans?
I can say that we can, let's say, pick one point in time. Let's define 10 million years ago, we had an organism that was, let's say, 50% similar to humans. And then a million years later, we have one that it's maybe 60% similar. And I'm saying that the degree of similarity gradually increases until we get to Homo sapiens. In fact, even after we get Homo sapiens, it continues developing until we get to our current form of Homo sapiens. It is a linear development.
Okay, so you're just repeating what you said before. My question to you is, can you take the sequence and say decisively that the humans today are the ancestors of those primates that you're referring to?
What I can say is, and look, because because I do think we are the descendants, and the evidence for that, and this is what you have to address, is that in literally countless places in the fossils, in terms of the cranial development, the development of our arms and our
You're,
legs.
you're repeating yourself again. I'm asking. You've said the same thing 3 times now. I'm asking. So these things.
Yes,
You put
I think it decisively shows. I think it shows we are the
decisively,
descendants.
it decisively shows that these are human ancestors.
Yes, I think it shows that.
Okay. Now that answer that you gave, is that categorical or is that inferential?
You mean inferential?
Yep.
That is. What do you mean? Can you define categorical for a second?
That is just conclusive. There's no other way of explaining it.
You could say that God created every single point in time, every few thousand years, as if it got closer and closer to humans. And you could say that's possible. And I guess with omnipotence, it is possible. So is that what you want to argue for?
No, I mean, you said you watched my debate with Aaron Ra, and
Yes,
this thing came up about Homo erectus and how do you explain it? Do you remember what my answer was?
No.
Okay, so all I simply said is, well, we as Muslims, we don't have a problem with the idea that they were non-human or human-like things, or the way we would define human is the children of Adam, things that existed before human beings, and they lived and they died, and we don't have a problem with it. Like that. That's not an issue.
Yeah,
It
but
is.
it's not just that it's similar. It's that over time they keep getting more and more similar sequentially.
Firstly, let's just clarify something. Yeah, apes exist today. Chimpanzees exist today. We have them existing in the past as well, and we have variations. And what we find is this. And come on, like let's stop messing around here. Yeah, in terms of the way that you're trying to show this beautiful picture in paleontology about this thing is into that. Every couple of years a new skull, and they move them around like musical chairs. Like this, right? This is well known. Every couple of years, Homo naledi. Oh my God, we just discovered it. Okay, now this fits here, and they move things around like musical chairs. The fact is, from a Islamic point of view, from a Islamic theistic creationist point of view, all we can simply say is, well, these things existed, they lived, they died, and you're using things like, okay, so they may have had language, they could have had even culture. Some anthropologists argue for that, and
culture.
And what we would say to that is, yeah, that's fine. We wouldn't challenge that. We'd say, yeah, that's fine. Like that for us would be things that existed before human beings. They lived and died, and that's it. Like it would not be like what you're trying to do is you're trying to make it a categorical argument. And all I'm saying is it's an inferential argument. And what we would say is, yes, we would accept their existence. We would accept, whatever information we have about them, but we wouldn't say they're our ancestors. So that's just a point of disagreement. But there's no way you can decisively show that I have to accept that those are ancestors. I can just simply say, well, those things were created by God. They lived, they died.
Well, this is the problem with. I don't want to use any me terms, but almost the language of absolutes, by which you can literally dismiss anything. You have a series of fossils that gradually come closer and closer to humans across literally dozens of species across millions of years, very sequentially, where we can trace where we can trace dozens, if not hundreds, of developments. And yes, if you want to say I cannot, if you want to say by definition, science is not absolute. Therefore, we can dismiss anything.
Look, John Doe. According to you, let's just get some things clear, right? You are assuming, firstly, an origination probability of close to 0. Firstly, do you agree with that?
Can you tell me what you mean by origination probability again? That it was created?
Look, your entire argument is an argument for homology, and the way that homology is based upon this. Now, what this is basically saying is that the origin of life is an extremely improbable event.
The origin of life?
Yeah.
I don't know about how.
The origin of life is linked to the development and the history of life. They're linked. There's no way you can unlink them.
Yes.
Okay. So the first assumption, which I don't think you're aware of, but I'm just making you aware of, is that the origination probability is close to zero. It is a near miracle, as what some Darwinists have called it.
Are you asking me if I agree that abiogenesis is a near miracle?
Yeah.
I don't know if it is a near miracle. I think there's
So
actually.
John, here's the problem. Yeah, you're using an argument for homology, and even these fossils that you're referring to is all an argument for homology. Yet the argument for homology has these two basic assumptions. It has the assumption that origination.
Like assumption.
Sorry.
It really doesn't sound like an assumption. I'm telling you about transitional fossils, and you're asking me if abiogenesis is miraculous.
But John, look, what's happening is this, yeah? You're looking at things from a very narrow tunnel vision perspective, right? You're looking at this is similar to this, therefore common ancestry. This is similar to this, therefore common ancestry. And you're repeating that like a broken record. I'm trying to get you to look at the entire tree of life. The idea of homology, two things are similar, therefore they have a common ancestor. When you go back, they have the idea that the origination probability is close to zero. Not like the Lamarckian idea that you have multiple origins of life, that the origination probability is closer to one. So that's the first assumption. The second assumption is you can have these macro evolutionary changes which happen through natural selection over time, which is again a assumption. And the assumption is that of a transition probability. And that transition probability assumption is close to one. For you to make the claim about the fossils, and for them to be ancestors of us humans today, it has to include these two assumptions. What you want to do is you just completely want to ignore the bigger picture, and you just want to say this thing's similar to this, therefore common ancestry. And I'm trying to get you to understand, look at the entire picture. Your entire argument is still based upon this. Now, if we switch around the origination probabilities and we say the origination probabilities are closer to one, then you can have multiple origins. You can have multiple origins. And if the transition probability is closer to zero, then you cannot say an ape-like creature evolved into a human-like creature because the transition probability is closer to zero.
Okay, let me comment on that.
1 second, John Doe. There's no way you can escape this right now. You don't know the entire picture. You just want to
comment on it. I will not escape.
All you want to do is say homology, homology, homology without looking at the picture.
Okay, let me comment on those because you keep saying I'm escaping it, and I'm really not. And listen,
look, John,
look, I will comment on it. I will comment on exactly what you want me to comment on.
Just a quick question. Just a quick question. Did you ever hear about origination probabilities and transition probabilities before this live stream?
I didn't hear about the specific terms, but I'm familiar with the concept, not the specific terms, though.
Look, the fact is, you're learning them live as we're speaking. You're getting free education here, yeah? So don't try and talk like you actually know what you're talking about, because you can't use an argument for homology without knowing the basics. But anyway, carry on.
Let me comment on exactly what okay, listen, I think I know more than the basics here. And I think that it's a red herring because I don't need to make the assumptions that you're saying I need to make. Let's say we simply don't assume anything about how probable abiogenesis or macroevolution is in advance, and we simply ask ourselves what is indicated by the fossil record and the data. Let's say I make zero assumptions. Look, I won't assume that abiogenesis is 0 or macroevolution is 1. I won't make any assumptions in advance about it. Yeah. So what now?
Okay, good. Thank you. What I'm going to do now is show why what you're saying contradicts the entire field of evolutionary science.
Go ahead.
The entire field. Go and pick up any book on cladistics. Go pick up any book on phylogenetic history. Go pick up any of these philosophers of biology or evolutionary theorists who speak about population genetics. You're saying, let's ignore the origination probabilities, let's ignore the transition probabilities. Let me just explain to you something. When you said these ape-like creatures are evolving into human, right? You are implying a transition, yes or no?
Yes, I am, based on the evidence, not the preposition.
Therefore, 1 second, therefore, you are accepting that there is a percentage there in terms of how things are transferring over. So you have to make an assumption about the transition probabilities, because If it's not possible for one thing to transition into another, if the transition probability is close to zero, your entire argument falls over. And the very fact you can't tell that this has an impact on your argument just goes to show that you don't actually know what you're talking about. You actually
I get your point. You're saying that if you assume in advance that it's impossible for things to transition, therefore what I'm saying is wrong. Of course that's true. That's very obvious. But do we need to make that assumption in advance? I'm saying let's not make any assumptions in advance about how probable it is, and then simply see and ask what the data indicates.
Okay, so let's do this, John. Let's do this, John. No assumption about transition probabilities. No assumptions. Okay?
Sure.
Is Homo naledi our ancestor?
Homo naledi?
Homo naledi.
I have not studied that specific one.
If we're going to talk about this and you're going to talk like you know what you're talking about, Homo naledi is a well-known... Okay, anyway. Homo erectus. You familiar with Homo erectus?
Yes, a little bit.
Sorry, there's a zombie that's about to arise from the sofa. Anyway, so Homo...
Look, Subboor, the thing is, the problem with what you're asking me is...
Wait, let's complete this point. Let's complete this point. Homo erectus to Homo sapiens. Do you believe this transition happened?
I don't know, but the thing is, I don't know. No, listen, I admit I don't know, but listen, the thing is, the problem with the question is...
No, John, we have to... We're at a very critical point right now. The critical point of that is you don't want to make assumptions about origination probabilities. You don't want to make assumptions about transition probabilities. Yeah. Now, if we take that on board, for you believe, say something like the Lucy fossil is our common, is linked to us. Do you believe that? Right? It's our ancestor in some way.
Can I comment for 1 minute?
Yes, you can, but I'm trying to show why your argument does not make any sense.
Okay, give me just 1 minute here.
Sure.
Yeah, so the thing is, regarding saying that this specific fossil or species is our direct ancestor, the thing is, you don't need to make that claim. Why would you need to make that claim if you can tell that? Why would you need to make that claim that is a specific direct ancestor? Okay. Why is that necessary here?
Okay, firstly, let's just keep things really simple with yes and no. Okay.
Can you answer my question?
Yes, I am answering it, but the reason, the way I'm going to answer it is for us to agree on what we agree about, so then I can show you your argument from homology, which previously you thought was not homology, but now you've seen it's homology, is based upon assumptions.
I did not change my mind about anything.
Well, you did, and it's actually recorded here.
Yes, yeah? It is. But look, can you answer my question? Does it matter?
Wait, hang on. Look, John, look. There's no point you saying you didn't change your mind when you initially didn't know you were using an argument for homology until you admitted it was an argument for homology.
No, I said it was an argument from the origins of a similarity, not a similarity.
Oh, come on.
Honestly, you know what? I would humbly ask you to actually go and read up anything about the philosophy of homology. Because at the moment, what you're doing is you're just using these popular understandings of it without actually looking into how it's used. For example, have you heard of the maximum likelihood method?
Okay, can you answer my question from before? I don't.
No. I found that you keep
jumping topics.
Okay. Wait. I'm not jumping topics. I'm the one who's basically asking you simple questions. Do you believe in human chimp ancestry?
Yeah.
Okay. Good. Very good. Do you believe that going back, human beings had a non-human primate ancestor?
Yes.
Okay, let's call that ancestor Sebastian. Okay, just for the sake of it, call him Sebastian, Sir Sebastian, right? So Sir Sebastian here, that you would, and that's why you keep going back to these transition fossils. You would say, okay, so this particular person, Sir Sebastian, and we have this fossil, okay? If the transition probability is close to zero, you cannot say that that is our ancestor, because transitions will not happen if they are highly improbable. So your entire point that origination probabilities and transition probabilities are irrelevant to the discussion of homology do not make any sense, because if we switch,
they're irrelevant. I said let's not make an assumption.
One second. If we switch the variables, if we make origination probabilities close to 1, that means we can have an origin of life in this room right now. And if we make the transition probability close to 0, that means two things, no matter how similar, could never ever actually have a common ancestor, because the transition probability is 0. And we haven't even started to begin about talk about the problem of homoplasy, because you also
misrepresented me.
It's with homology.
No, you misrepresented me. I did not say it was irrelevant. I said let's not make assumptions about what it is, because we can easily make any assumption we want based on nothing and end up with completely different conclusions. Let's not make assumptions.
Very good, John. So let's do this. What right now in the field of evolutionary biology, what assumptions are made about the origination probabilities and transition probabilities?
Look, I don't think it's an assumption. I think it's actually based on data. I think we can say based on data that there is a certain probability.
It's not.
Yes, it is. And I'm trying to talk about the data.
John, let me just tell you something. Yeah, you're actually making blanket statements with zero evidence, absolutely no evidence. Let's just start off with abiogenesis. This event that happened 4 billion years.
Well, can you answer my question before?
One second. You said it's based on data. I'm telling you it's an assumption. Yes. So let's see who's wrong. Who's wrong and who's right here. Yeah. So abiogenesis, you're saying it's based upon data. I'm saying they have made an assumption that the origination probability is close to 0. Now, I'm going to give you evidence for my worldview. You give me evidence for your point of view. Okay? Is that fair?
You want to debate abiogenesis now?
No. Stay with me. Yeah. Look, abiogenesis, you're saying origination probabilities and transition probabilities is based on data. It's not based on assumptions. So I'm saying, no, it's based on assumptions. Now, when it comes to abiogenesis, I'm going to show you right now that abiogenesis is based upon origination probabilities close to 0. You need to show me that it's based on data, because that's the claim that you made. Is that fair?
Can I clarify something? Are you asking me to show a specific percentage? Or what specifically do you want me to prove?
No, I made the claim that the transition probabilities being closer to 1 and the origination probability being closer to 0 is the assumption in evolutionary biology. That's the claim I've made, and that's the claim I can show you. You made the claim there is no assumptions being made. You made the claim is based on data, not assumptions.
Yes, I claim there is data behind how probable we think events are.
Good. So let's do this now. Let's have this cowboy showdown, right? Let's start off with abiogenesis. So if we look at what evolutionary theorists say about this, people who are looking into the RNA first model and all these different types of models, they would make the assumption that there was one origin of life. Richard Dawkins, in The God Delusion, in all his other books, he always talks about the initial stroke of luck. When we look at the works of, say, Elliot Sober, the philosopher of biology, or we find Alex Rosenberg or these other atheist philosophers of biology, what do they talk about? Again, one origin of life. Okay, so this assumption is there in the literature. You're saying it's not an assumption. You're saying it's based on data. So give me that data.
That there is one assumption? That there's one origin?
Yeah, I gave you the evidence that the field of evolutionary biology makes the assumption that the origination probability is close to 0, meaning a near miracle. You're saying there's no assumption, it's based on data. Now give me the data.
Oh yeah, I wouldn't make the claim that there is necessarily a single origins to self-replication machinery.
It doesn't matter what you think. I'm asking you for data.
I didn't say what I think. I said what I don't claim.
Is irrelevant. I'll just brush it away. Who cares what you think? I'm saying let's talk.
What I think. I said I'm not making an assumption. All I said was I don't make the assumption that there is necessarily a single origins to self-replicating machines.
My friend John, it doesn't matter what you think. Honestly, it doesn't matter what
I don't think. I'm saying what I don't think.
It doesn't matter what you don't think. It doesn't matter if you do think. It doesn't matter what you say. I'm sorry. We're talking about what the academics say. We're talking about what the evolutionary philosophers say and the biologists say and the theorists say. Your thoughts are irrelevant. I'm sorry. They're just
so
not.
wait, you're saying that according to the origins of life field, there's one origins?
Currently, the model that they're using, they are assuming origination probabilities closer to 0. Therefore, one origin of life. That's the common idea that they have.
And you're saying this is according to origins of life researchers?
Yes, this is according to evolutionary theorists who are working on the origins
of life researchers. This is a specific field.
People who are looking into abiogenesis. Yes. Have you? Firstly, are you aware of origination probabilities and transition probabilities debates?
Debates? No, I have not read about the debates of these.
Okay, so look. I'm sorry, John. Yeah. Like, if you don't know this stuff, then it's hard for me to take you seriously when it comes to this field.
Okay, no, but I'm asking you a question about what you said. Listen, don't take my opinion seriously. I'm just asking you to clarify.
Sorry, don't assume I am taking your opinion seriously. I'm
okay,
not.
Okay, Subboor, but look, can you just answer? You said
I'm actually laughing at it. Yeah,
okay,
I'm honest.
Listen,
I'm honestly trying to make a very simple point. I'm honestly trying to make a very
simple question.
No, that's fine. Look, John, I'm just honestly trying to make a very simple point. You cannot speak about advanced, rocket science if you don't understand Newtonian mechanics.
I'm not doing that. Don't worry.
One second.
Can I just ask you?
You cannot talk about homology, homoplasy, which we didn't even get onto, similarities genetically, anatomically, biochemically, which are not due to common ancestry. We cannot speak about any of these things until you understand origination probabilities and transition probabilities. And let me just be absolutely frank and fair with you. You never heard of these terms till you jumped onto this live stream, did you?
No, it does not matter.
What do you mean? What do you mean it doesn't matter? I'm sorry.
Because I'm not. Wait. You refer to assumptions.
I'm sorry.
You refer to assumptions that
I don't make. I'm sorry, John. I'm a botanist. I'm a botanist, and I've never heard of photosynthesis. What would you think of me? You'd probably give me a foot slap. Yeah. The fact is, you're here talking about homology, and you've never heard of origination probabilities and transition probabilities, which is the bread and butter of homology. You've never heard of this?
No, I haven't heard of the specific terms. I'm familiar with the concept.
Wait. I'll tell you what. I'll tell
you latching onto this. Can I ask you a question?
Yes. I'll tell you exactly why I'm latching onto this, because this is standard.
It's semantics. That's why.
No, this is okay. Okay, let me tell you something. The concept of photosynthesis can be known without photosynthesis. Correct?
Okay, can we not keep jumping points? I have a question.
One second.
You've not answered any of my questions.
1 second. I've answered all your questions.
No, can I ask you? You said according to an origins of life researcher. Can you just pause for 1 second?
Just 1 second. You're trying to defend yourself because you don't know these things. But let me just ask you something. Can I describe the concept of photosynthesis without knowing the label of photosynthesis? Is that possible?
You can actually describe the mechanism without using the word photosynthesis.
Good. However, if I claim to be a botanist, if I claim to be a biologist, and I don't know the term photosynthesis, you'd have reason to be skeptical of my credential.
Did I say I was an origins of life researcher?
No, you did. I never said that. But you used homology. You used the argument for homology.
Okay, so you're saying in order to make the argument of homology, even though I understand the concept, I need to know the term in advance?
No, what you do need to do is you need to understand that these are the terms being used by the experts. And if you're there to make an argument for homology, you need to know these terms. And secondly, you just said a little while ago, and anybody can go back and timestamp this, you said the argument that you were making in terms of the transition fossils, you said the assumptions are not actually there. It doesn't matter what the assumptions are there. We can stick to the data. Didn't you say that?
Yeah. I said we don't need to make assumptions.
Yeah, and again, let me just highlight this point. And it's at 3:49:44 seconds. Someone can timestamp this. That is flatly wrong. You have to make assumptions before you continue in evolutionary biology. You can't do anything without assumptions.
The assumption that I would make is that it's not necessarily 0 or 1.
I'm sorry, who cares about what you think? Yeah, I'm sorry, no one cares about what you think. I'm trying to make the point.
It's
Wait,
honestly your this is a red herring of the
one
greatest
second.
magnitude. This
One
is
second.
the
One second. I don't care about your opinion.
neither I yours. Can you
All
answer
I'm
a
trying to
question?
highlight is you cannot make an argument from probability until you have assumptions, and you said you can. And I'm saying it's impossible. It is impossible to continue to have an argument from homology without making assumptions first.
Subboor, I said I don't assume that origin is 0 and that transition is 1.
Okay, let me just repeat this one last time. Yeah, I don't care what you think. I'm talking about how evolutionary academics look at this.
Okay, I
It's
don't
not
think
about the assumptions
they
you make.
presuppose that either. Okay, listen, can I ask you the
By
question
the way,
that you made?
by the way, let me just explain something. Yeah, I gave you evidence. I gave you evidence
No, I
for the.
don't. I think you didn't, and I want to ask you
Wait,
about that. I
okay,
want to ask you about that.
one second, John Doe.
I don't think
Only,
you gave the
look,
evidence.
John, we have 512 people watching, and they've all witnessed something. I gave you evidence that the origination probability is assumed to be 0 in abiogenesis. Okay.
Okay, who were the people you quoted?
Huh?
Who are the people you quoted again? Because that's what I asked about.
I quoted Elliot Sober, Alex Rosenberg, Richard Dawkins, the most famous Darwinist in the world. You
Richard
can look
Dawkins is not an origins of life researcher.
Okay, fine. He's not, but you have evolutionary.
What were the other names? What were the other names?
Elliot Sober, Alex Rosenberg. Look them up.
Elias, how do you spell sober?
Oh my God! If you don't know who Elliot Sober is, why are you even talking to me? Like honestly,
I'm not an origins of life researcher. I'm sorry, but can you?
Well, why? Okay. Well, do you know what? Why are you trying to argue on something that you're ignorant about?
I'm asking you to clarify, brother.
No, if you're asking me to clarify, I'll be happy to give you education. But if you're trying to challenge me on something you're not educated about, I'll have to point it out. Look up Eugene.
Your argument is that I haven't heard of this specific guy.
Okay, so let me just explain something. Yeah, when it comes to abiogenesis,
you demonstrably quoted someone who is not an origins of life researcher.
Okay, wait 1 second.
I want to check if the other guys you quoted are relevant.
Wait. Hang on a second. Yeah, Elliot Sober is a philosopher of biology, so
that's
therefore
not an origins of life researcher. Why would I hear about him?
Wait, John, you're being extremely ignorant right now. You haven't even let me explain who Elliot Sober is and why he is taken as an authority when it comes to abiogenesis research. You didn't even let me complete my sentence, and you're saying he's irrelevant. Let me explain
how a philosopher. Go ahead.
Let me explain to you why he's relevant. Let me explain to you why he's actually relevant.
Go ahead.
Let me see if I can. Can you just grab? There should be a book over there. Elliot Sober on this shelf. Hang on, just 1 sec. Giving free education.
Some girl needs to come so I can slap him. Everything. I'm gonna slap him, though. Yeah. How long was I asleep for?
An hour.
So long. No way. Is it muted?
No. I need to find this book.
Well, I slept for an hour and a half. Why? I needed to sleep, you know. I would have crashed the car. Don't come over here. I strangle.
Bro, the things on. Careful.
I'm the strangler. I feel like biting.
Nice circle.
Well, I slept for an hour and a half, yeah. My God. That's a bad one. No, it was too dangerous for me to drive like that. Yeah. But I snored last night. I was asleep. Yeah.
All right.
Like,
These are just some starter books, but the one of the books I was looking for, I couldn't actually find. I think I've got it at home instead. So, Conceptual Issues in Evolutionary Biology, and this other one about parsimony, phylogeny, and genomics by Victor Albert, right? And there's another one, Evidence and Evolution by Elliot Sober. These three books. But let's just go with the one that's the freshest in my mind, which is Evidence and Evolution by Elliot Sober. In this book, what he basically covers is that the origin of life probability is linked to the transition probability, is essentially linked to the entire tree of life. So if anybody's to make an argument from, say, for example, have you heard of the maximum likelihood method?
No, I don't remember what it means.
You know, honestly, there's okay, forget it. Maximum likelihood method is what they use to actually work out phylogenetic genealogy. Okay, that's how they work out what's linked to what. So this has to look into, for example, have you heard of homoplasy?
Yeah.
Okay, so that's how they would look at. Okay, so if this thing is homoplasy and this thing, if this thing is homology, how will we assume this? And they'll do their Bayesian probabilities and all that type of good stuff. However, all of this stuff, and by the way, this is being live streamed. I'm not going to delete this. You can go back and prove me wrong. You can actually take this clip and prove me wrong. All of these things are ultimately still based upon assumptions that they make about Bayesian probabilities, assumptions that they make about transition probabilities, and assumptions that they make about the origin of life probability. Hence why, and the reason why I mentioned Richard Dawkins, which I don't think you understood, is that he is a popularizer of evolutionary biology, but even he recognizes that the origin of life is actually something in which the origination probability is closer to zero. Eugene Konin, who is again an expert when it comes to abiogenesis, he also, you can look up his works. He will also show you that actually the origination probability that they assume is closer to zero. Hence why they refer to it as a near miracle. So for you, John Doe, to make any argument of homology, whether it has to do with biochemistry, genetics, anatomy, you have to make assumptions about originations and you have to make assumptions about transitions, because if transitions are closer to zero, you can't say this thing evolved into that. And if the origin of life probabilities are closer to one, then you can have multiple origins of life and you can have multiple things which are looking similar to each other, but they do not have a common ancestor because they evolved independently, which is the idea that Lamarck actually had. So I hope now you get a broad-based picture, and you're not going to make these categorical claims that you're actually making, which are, to be honest, quite absurd, especially if you don't know the basics.
Okay,
Yeah.
so listen, I was trying to make as few categorical statements as possible. I will not make claims. Look, I've read a lot of Eugene Konin's papers on virology, just as a personal interest. But look, I can accept your claims, and it would not modify my earlier statements if you have multiple origins of life. Because remember, the example I brought up concerned transitional fossils with primates. Whether or not there's one or multiple origins of life, that does not modify anything I said on that topic.
Okay, good. Let me explain to you why it does. You said the word transitional fossils.
Yes.
Okay? If the transition probability is close to zero, could you have an ape-like ancestor of a human being?
If the transitional probability is zero, if it is zero, then you cannot evolve, of course.
Okay. Do you now see why transition probabilities are important in evolutionary biology?
Yes, they're important. But could you agree that you can proceed without necessarily assuming a specific value or a region for value?
Absolutely not. You cannot. You cannot. You can absolutely never do that. You have to make that assumption before you continue.
Okay.
Do that.
So are you fine if I said it's possible in advance?
Sorry, I don't understand. Explain.
Yeah, all I'm saying is I will, because 0 is impossible, 1 is will happen. Anything in between is possible. Different ranges of possible, but nevertheless, different levels of possibility. So all I say is it's possible. I don't know if it's going to happen. I don't know if it did not happen, which is maybe closer to 1 or closer to 0. And I just want to ask myself, given that I do not know in advance how likely it is that an ancestor became a human, that is also the ancestor of another ape, given that I don't know in advance if it's 1 or 0 or in between, maybe I can look to see, maybe I can look at fossils and ask myself, does it appear as if, for example, there's a sequential step of fossils leading to humans?
That would be putting the cart before the horse.
I think it's the reverse of that, because I said, because I don't know if it's going to happen or not, I want to look, I want to see as if it looked like it did happen.
The problem here is you're putting the cart before the horse. It's a non-starter. If, for example, you take fossil A, oh no.
John Doe,
Okay.
I just want to ask myself, is life worth living? Should I blast myself?
I don't know what yeah, go back to sleep, bro. Go back to sleep. Sorry, he just woke up. Go back to sleep.
I think he's drunk.
Sorry.
Is life worth living? Should I blast myself?
Bro, go back to sleep. So sorry, he was literally sleeping, and then he just woke.
Changes, bro.
Okay, so the point that look, John, where we could agree is I have the viewpoint that you cannot make that inference. The claim that you made right now, I think, is improbable. I think it's extremely difficult to hold that view. That you are simply going to look at fossils and then make a transitional probability from there. The reason why is because the transition probabilities and the origin of life probabilities, they act like lenses which colors the data. Okay, there is no such thing as a perspectiveless perspective. You're simply going to look at transitions and you're going to say this thing is linked to this. Why? Because if origination probabilities are closer to 1, then you can have multiple independent origins. And if transition probabilities are closer to 0, then there's no way that human beings can be in transition from something else. It's impossible. So the data that you're referring to can only be understood once the lenses are set in terms of origination probabilities and transition probabilities, or else you're putting the cart before the horse. Yeah. Now,
no, listen. Let me put it a different way, because I really think there is a way to gain probabilities from data. I think there is a way.
Okay. Do you know what? I'll tell you this. I don't really care, and it's good if you do, if you think this, but I don't really care about that, because that's not something which I'm aware of. Anybody's made that argument. What I am aware of is that 0 or close to 0 is the origination probability. Close to 1 is the transition probability. That's the way that is currently working in evolutionary biology. If you want to come up with something alternative to that, good on you, right? But currently, as it stands, it's irrelevant.
I'm not coming up with an alternative. Not necessarily. I'm playing into the setup you've given me. I'm saying if we took that, if we took what you say, which is you don't want to make any assumptions, I think I could still take what you're saying, and I could still, I still don't think creationism could really be inferred from any data. And I think the data,
Okay,
if you just looked at it,
you
would suggest evolution.
You've made a jump there, right? And again, this is a huge problem. That firstly, we weren't in this particular conversation. We weren't talking about the last part of the conversation. We weren't talking about creationism. However, you've made again that jump from biology to theology, and you've said, for example, I don't see how this fits in creationism. Are you aware that people like Asa Gray, who were in contact with Darwin, they were creationists, but they believed in universal common ancestry, and so for them, something like ERV would be no problem, but they were pure creationists.
Are you referring to like Adamic exceptionalism?
No, Asa Gray, he was a contemporary of Darwin.
I know about him, but what did he say?
He said the exact opposite of what you're claiming, which is that he accepted and he would have no problem with ERVs or universal common ancestry. He accepted universal common ancestry. He accepted all of this. He just believed that God created everything through natural selection. That was his view.
Yeah, that's God-guided evolution, but that's still evolution.
But he's a creationist, and you said it doesn't fit with creationism, which is simply not true.
Okay, sure. If you want to define creationism as any involvement of God, then sure. In that case, you could say that God guided. What I'm referring to here.
Firstly, do you understand why I keep saying you're misrepresenting the creationist position? Do you understand why I'm saying that now? Because I just showed you right now, you just made a claim about what the creationists cannot accept, and I just showed you a creationist that accepted exactly what you said they can't accept.
I think you've just used a term that I was not using in the same way. I honestly think that it's not useful to keep delving into semantics when the actual fact is agreed on.
It is important to delve into semantics if you're going to commit the fallacy of equivocation.
I'm not equivocating. Let me agree with you. What I'm referring to, if you strip the labels.
Firstly, do you agree with me that you've made false statements when it comes to origination probabilities and transition probabilities, and when it comes to the creationist position? Do you understand the mistakes that you made here?
The origins, as in people don't make assumptions about it?
Yes.
Sure, I would have to look into that, but I could have made a mistake.
You can look into it all you like. I was trying to show you that you're actually making claims about the field which are false, and the claim that you made was that there are no assumptions being made, and I showed you assumptions are being made.
Did I say no assumptions?
You said it was irrelevant what the origination transition probabilities are, and you were just wanting to speak about the transitional fossils. That's in the recording.
Yes, I did say that.
Yeah. So do you agree that was wrong?
No, I think you've misunderstood what I said. Look, let's say I was wrong, but I think my point just remains unchanged. Let's say I was wrong about that. But my point, I mean, you could say that I misdefined creationism, and therefore I was wrong.
Okay,
I mean, you can play that game all you want.
Firstly, what it is I'm trying to point out that you are making claims about homology without understanding actually what homology is based on. And the reason I did that is not just because I enjoy showing that people are wrong. I enjoy showing that people are wrong when their claims are wrong. I'm not just doing it for the sake of it. I'm actually trying to make this conversation elevated. I'm actually trying to show it's far more complicated than the crude assumptions of, hey, look, two things are similar, therefore they have a common ancestor. Look, this. Like, that's just childish stuff. I hope you do understand now that origination probabilities and transition probabilities, one, exist, and two, they help us infer whatever conclusions we're going to make.
Sure.
Alrighty. What else do you want to discuss? Do you believe in God?
Me personally, yes.
So you believe in God. That's good. So do you believe God can create through evolution?
I believe it's possible that God can guide evolution.
Okay. So from that perspective, you are essentially a creationist, like me.
No, I said it was possible. No, Subboor, listen. I said it was possible. I did not say I believe that.
Okay. But you believe in God, correct?
Yeah.
So do you believe God decrees everything? everything that we have in the world is decreed by God?
I don't know that everything is decreed. I don't know.
Okay, do you believe everything's created by God?
I believe that the initial point was created by God.
Okay, so you're like a deist. A deist.
I would say I'm ambivalent
Okay.
in the sense of God's specific involvement.
So kind of like, are you a bit like an Einsteinian? I mean, that's your sort of perspective, where you believe not a personal God, but something greater than us, and that kind of thing.
I don't know. I'm ambivalent. I don't know if it could be personal. I don't know if I want to look. Let's not put labels on this, right? I'm simply saying I'm ambivalent towards God's specific involvement. It could be very personal.
Okay. Okay. So you're not quite a deist. Okay, that's fine. That's fair enough.
Could be.
So from your perspective, why would say the creation of Adam, right, which we believe in, why? Or maybe I'm wrong. Maybe I'm completely wrong here, and I'm just being stupid. That this is not the position that you hold. But let's just go with it. Why would you say that is improbable or impossible or unlikely to happen? The fact that God creates someone in time that is, the father to all human beings. Why would that be difficult for you to believe?
Well, it's possible that there was because there was always a population. I mean, there was always a population of human beings, as far as any evidence ever indicates.
Yeah, and do you know how they inferred that the initial population that they have? Sometimes they say 10,000, sometimes they say 1,000. Are you aware how they calculated this?
I know it's not an exact science, and I don't need it to be. And you could say, listen, you could say that if you go back to a certain period of time, you can go back to a period before molecular phylogeny says anything about the population, and therefore you could make any claim at that point what the population was, and that would be outside of what molecular phylogeny can confirm or disconfirm.
Yeah.
But the thing is that, listen,
I agree,
because earlier we talked about a few things, and it's all about what would we because there are expectations here. Because when we talk about ERVs and transitional fossils, we made the observation that there are identical viral patterns of insertions in different species, and we made the observation that there appears to be, let's forget about transitional, but there are a series of fossils that look increasingly like humans. And when you take a look at that from a bigger framework, you can still say, per your statement, that okay, well, in order to say that did happen, you're saying that the transition probability is non-zero, which is an assumption, which means I don't need to accept it, and it's not conclusive or not categorical, whatever you want.
yeah.
But at the same time, it is so concordant with a process of linear development, and it seems so presuppositional. I mean, just to say that this appearance of linear development is completely artificial, because God made it look like we evolved.
No, but again, what you're doing here is you're saying two different things, right? You're saying, let's assume that there is no let's not assume a particular transitional probability, but then when we look at things, it clearly looks like things went through this linear evolution. But for you to say if things went through this linear evolution, you're obviously accepting that transition probabilities are high.
Okay, let's just say, would you agree that it looks like, I'm not saying that it looks like we have a linear development?
I would say what it looks like depends on what you believe the transition probabilities are. I believe the transition probabilities are low. The reason why is because I believe the Darwinian mechanism is overhyped and it's a conservative force, and the evolutionary mechanism of working on random variation leading to these mass evolutionary changes, I think, is a fairy tale. The blind the thesis, I think that makes me really think that the transition probabilities are low.
No, but it's still possible for no, it is possible in a hypothetical world for the transitional probabilities to be low, and it still looks like there was a linear development.
But in a hypothetical scenario, it is also possible that you have an independent human origin as well.
Yes, I'm not referring to that. Listen. What I'm saying is that because I asked you if you would agree if it looks like a linear development happened, and you said no because I think the transition possibility is low. All I'm saying is that that's not mutually exclusive. It is possible for the transition possibility to be low, but it still appears as if there was development.
No, because if it appears as if there was development, that appears as if it's still using some sort of transition probability.
No, because not necessarily. Let's say, for example, because I'm going to play into what you said. Okay, let's say God created.
Sorry, John, to interject here, and sorry about the laugh and the banter. He was going a bit crazy before with this guy coming and starting to trying to rap and stuff. Yeah, I just want to ask you a very simple question, which is, do you understand my perspective that it is impossible to have a perspectiveless perspective when looking at transition or these types of fossils, because you always have to make a presuppositional commitment to origination probabilities and transition probabilities? That's the argument that I'm making, and I'm making that based upon my reading of abiogenesis and evolutionary biology at the moment. Do you understand that that's what my perspective is?
Yes. Can I paint a scenario for you on your perspective? Let's say that God created 10 million years ago a primate that was 50% human. And then 100,000 years later, God created a primate that was 55% human. And then it goes on. And in fact, let's say that you have a primate that's created every single time, 58%, 59%, all the way to 98, 99, and then 100, and all of these come chronologically after each other. And let's say we accepted that every single time that was a special creation. In this case, and let's also say that the transition probability is 0. In fact, in this case, in this scenario, we have a 0 transition probability. God created every single ape or primate or whatever, and it looks like there was the development, even though that's not the case.
Yeah, I would say that that way that you explained it would be false. The reason it would be false is it cannot look like a transition if the transition probability is 0. It just cannot do that. It's impossible.
Why not? Because I could, for example, paint something that looks like a human, even if it's not a human.
No, you can do that, but me as a theorist, if I believe the transition probability is close to 0, then for me, there is no evolution there. For me, these are just independent. And by the way, we as Muslims, just to let you know, theoretically, we are ambivalent to the idea of all of life and its evolution and this type of thing. Our minimum commitment is that Adam is a miracle, just like the miracle of Jesus, just like the miracle of Moses parting the sea. That's our bare minimum commitment that we make, right? I'm just throwing that out there just in case.
Okay, I think there's a degree in which what you disagree with is based on only the words I'm using, like the specific terms I'm using, rather than the concept. Because I want to put this in a way in which it is, in which you simply.
Can I steel man you, and then you can tell me if I got it right?
Sure.
What you're basically saying to me is, if I assume the transition probability is 0, yet if they are continuous, what's it called? If there's a ape-like creature, and after some years there's another ape-like creature but has more human-like features, and then you have a human, and then you have, in fact, let's just do it incrementally. Every year you have a 1% closer to until it looks like us. The thing is, if the transition probability is 0, and I believe that, then all of these are independent.
Uh, yes, yes. The fact of the matter is, in that scenario, it is independent. But I mean, there must be a way to phrase this in which you would simply agree that
Do you
if
understand why I'm saying that though?
um, I think it appears to be because you want to emphasize you believe it is zero probability.
No, it's because what I'm trying to show. Okay, here's another point. Here's another way of putting it, and I really enjoyed this back and forth because it's helped me to bring out an idea which I didn't think of before. If we have a dinosaur-like creature, and then we have a fossil human, and in between we have nothing, and I believe the transition probability is 1, then for me this is a clear evolutionary ancestor.
Yes, but it would not appear as if it was, which is what I'm referring to.
So it will appear to me with the transition probability of anything that I find with a human, even if it's a pig with a goat's body, I would say that is a human ancestor. Do you understand why?
Yes, you would think it's an ancestor.
Yes, that exactly.
But it could not. But look, if you had like a dinosaur and then a human a trillion years later, it does not appear to be a linear development.
The word appear only comes to the fore depending on your origination and transition probabilities.
To be honest, I'm not. What do you mean by that?
Origination and transition probabilities color all the data. They color even the way that you describe the data.
Look, I disagree with that because I can say even if I believed every percent from 50 to 100 is a zero transition, I would still say, if I agreed to that, I would still say, assuming a zero transition probability, that it appears like a transition.
Why would you say that when you know it is impossible?
I'm not saying it's possible. Here's the thing: saying it appears is not the same as saying it's possible.
If you say the transition probability is zero, you are saying it's impossible. You are saying it's not true. So then why would you say it appears to be true?
Because you can have something you know appears to be a way, but it's not true. For example, if I had the
listen. Yeah, I see what you're trying to say. You're basically saying it's like the illusion of design. It appears to be an illusion, but it's actually like that kind of thing. What you're basically
exactly.
trying is that okay, that's possible, but it's linguistically incoherent, and that's why I'm finding it very hard to agree with it. But fine. If somebody, okay, here's another way of putting it. Someone who
you hit the head. You hit the head. You said.
Okay, so wait 1 second. Someone who's never heard of origination probabilities or transition probabilities, right? They have a deep-held belief that anything is elastic. Things can evolve. Things are fluid. So they believe in transition probability of close to 1. They look at the data, and it does appear to them that this is the case. But someone who believes in natural selection working on random mutations, it is a petty mechanism that is conservative. It doesn't actually create. They will look at this and they'll say, nah, it's not going to work. So do you understand why this is absolutely central to any conversations about homology? Why it's absolutely essential that we have discussions about origination and transition before we speak about homology. Do you agree with that?
Yeah, sure. I think that if you presuppose a 0 or 1.
Progress.
Okay, but I think, but you did make a point that I want to go back to. You said there is an illusion of evolution. So would you agree with that wording, from the 50 to 100% with 1% increments?
Okay.
Would you agree that there is an illusion of evolution then?
No, I would say there is evolution, because I believe that.
What I meant is there is an illusion that the 50% transitioned to 100%.
Depending on my probabilities that I before I look at the data.
So even then, you would not even say it's an illusion.
For me to, and again, I think this is where concepts are very important. You know, I can't get into color theory if I'm colorblind. I can't make assumptions about what's possible and what's not possible and what's likely and what's vision until I already have made beliefs and commitments about origination and transition probabilities. Do you understand that? Yeah.
Yes.
So, John Doe, it was really fun speaking to you. Can you put your email in the private chat, and I'll email you. And we'll continue this another time. Is he sleeping? Is he awake? Is he awake?
Do you mind?
Because it's actually nearly 3 o'clock in the morning, and we need to go home. So we've been live for about 4.5 hours.
Do you mind if I email you?
Sorry? Yeah, no, I wanna email you. I wanna talk to you. You're actually a really cool guy. It was nice to meet.
Yeah, I will, but I want to use this specific account for the emails if you don't mind. So I'll email you.
Okay. Do you have my email address?
Could you say it?
1 second. Can you see the private chat?
Yeah.
Darwiniandelusions@gmail.com. Can you see it? Yeah.
On darwinianevolutions@gmail.com.
Yeah. I put in the private chat.
Let's see. It's kind of, I don't know. I don't really see it, but I can just.
Okay. Here's another way of doing it. Can
okay,
you?
I see it. I found your Twitter on it.
Yep. You found it. Yeah. Okay. So wait 1 second. It's also on the screen right there.
Yeah, I got it.
You got it. All right. Good. It's really great speaking to you. I'm guessing John Doe is not even your real name.
No.
Is your name Zangief by any chance?
Wait, what?
Sorry, it's too late. My brain. Zangief from Fire. I just thought of that. Sorry, I was just really tired and a bit crazy at the moment. But yeah, it's really great speaking to you. Let's speak again. It was a really interesting conversation. But let's continue this via email. And yeah, you should. We should have this another time. We're live every Saturday, so you can join us next Saturday as well.
I'll email you.
Yeah. All right. Have a. Where are you calling in from, by the way?
Canada.
Canada. So what is it? Daytime, yeah?
It's kind of on the border right now.
Oh, is it nighttime, yeah?
Looks dark.
Okay, it's like 3 o'clock in the morning here, so I'll speak to you later. It was good speaking to you, John.
All right, goodbye.
All right, goodbye.